Okay. I was actually busy with a completely different lesson. That's why this thing here, it starts showing some other stuff. But otherwise, it's fine. As I've indicated, for now, we are going to be looking at something completely different, being number patterns. Let me just insert some blank pages there. Let me just insert some blank pages there, just so that at least I'll have enough space to be writing. Yeah, I hope for a second you did not think that what's going on, because I wanted to attend a mathematics lesson related to a number pattern. Okay, so without wasting much of our precious time, I will therefore just indicate there to say, indeed, number patterns is what we are going to be looking at. Okay, so honorable member, we've got something called number pattern. Maybe let's just start there and say what exactly is number pattern. I will just indicate to say it's just a list of numbers, honorable member, which are arranged in a specific order according to a rule. That's it. I don't want to go much into the definition and all of that, because sometimes it happens when you study on your own. You try to make sense of the definition when something doesn't make sense. Maybe they give you a problem, try to work it out, it's complicated, you try to remember, what does the definition say? Can I use the definition to understand this or work it out and all of that? Not worry that much about all of that. Just know that when we talk about a number pattern, it's just a list of what? Not a list of potatoes, but a list of numbers. You know what a number is most. So that those numbers must be arranged in a specific order. Very, very much important. We don't just talk about numbers which are in a form of a list. Nope. Must be arranged in a specific order. And not just that, but according to a rule. So that means we don't just look at one followed by two, and then next thing is 1,000, and then from there it's a million. No, it must be numbers, yes, arranged in a specific order, yes, but according to a certain rule. So we've got types of number patterns, but for today, we are only going to be looking at this type of a number pattern called arithmetic. I don't know whether you wear a blazer when you go to school, or you are like me where you wear a pullover. But yeah, if you wear a blazer, you can refer to this type of a number pattern as an arithmetic number pattern. But for me, I used to call it linear because, yes, I don't want some big words. Linear pattern or arithmetic doesn't really matter that much. Arithmetic, it's either arithmetic. And the day, it's a number pattern. Number pattern, yes. Okay, maybe what is it that you need to know about a linear or arithmetic pattern? So the pattern increases or decreases by the same value each time. It does what? Don't say ceases. Does it increase or does it decrease? I don't want to hear you saying ceases, but it does both, honorable member. It can increase or it can decrease. At the end of the day, what we know is that it is by the same value. For that reason, we will call that same value a common value. But I will explain in detail regarding what happens. Maybe let me just give you a quick example regarding a linear increasing or decreasing. So you can have 2 followed, let's say, by a 4, followed, nope, what am I doing there? Followed by 6, and then followed by 8, and so on and so forth. Or can be like this, where it's now 8 followed by 4, not 4, but 6, followed by 4, followed by 2, and so on. So can you see, increasing or decreasing? So don't worry that much about that. What matters the most is that you need to be aware of the formula that is related to this type of a pattern. That formula, it's not a complicated one, to be honest with you. That formula says Tn, it is equals to A, that you plus it with N, where you minus 1, and the whole of this you multiply it by D. So what you should be curious about is to say what exactly is represented by that Tn, A, N. One is a number, and then what about that D? So what you should know is that A, alphabetically, A is the first letter in the alphabet. So here they deliberately chose letter A so that it becomes easier to say A refers to the first term or the first whatever that you have in that sequence. So that means on those two that I've given you, this thing in there, it is your A value, or it refers to A. If you had to substitute in that formula, then if you are dealing with that number pattern, then it would be that 2 that goes into that A. So now we have just explained what that is. Okay, then it's fine. The next thing, maybe let's start with the easy one to explain. The D. What is the D? The D is the difference. The D is the difference. What is meant that by the difference? The difference, that's if you take something, you minus something. Maybe let's say this is the pattern that we can use as an example and say, okay, difference means take this minus this. For example, the sum means take this plus it with this. Is the product where you multiply. So the difference in this case, you take this, you minus it by that. It will give you the difference, of which is 2. So you just do it in this manner where you say the number after you minus it with the number before, it gives you the difference. Like you say 6 minus 4. What is that? Is it not 2? It's 2. Okay. What about when we say 8 minus 6? What will that be? Is it a million? No, it's 2. Hey, one. Can you notice something, honorable member? Each time when I get the difference, I get the same answer. This answer is common. It's 2. And I get it when I do the difference. So that is why we will therefore call this not just the difference, but CD. What is CD? C for common, and then D for difference. So I used to call this CD, honorable member, whereby it's important to say C because it has to be common. You can't have 2 there, and then there all of a sudden you have million, and then for some reason there now it's back to 2. Nope, it has to be common difference. So that is what is meant by the common difference. So if you are given a linear or arithmetic number pattern and you try to calculate the difference and it doesn't common, then you know that you've got a big problem because that difference has to common. I hope you get my point when I say it has to common. In other ways, you have to get the common difference. So I think I've just explained easily. Maybe let me just throw in a nice word there and say, in a nutshell, I've just explained exactly what the difference is, even though on the formula we don't have to say CD, but we know very well that it is actually not just a D, but a common difference. Very much important on that one. Okay. The next one is N. Yo. How am I going to explain this one? Because N is just the position number, honorable member. It's just the position number to say first term, second term, the 10th term, etc. That's it. That's it. I am telling you now, it took me a very long time to differentiate between N and Tn. Not that is difficult to see the difference, but I mean in terms of understanding how do I know whether I'm calculating n, and after calculating it, does it really make sense and does it suit to be n? What about Tn? How do I know when I have to calculate Tn? It's like when the question comes, how do I know I'm calculating this? How do I know I'm calculating that? That is the only challenge that I had. But regarding calculation, because I was good in mathematics, I would easily calculate. But the challenge came when I had to know when a question comes, what do they want? Is it Tn or is it n that they want me to calculate? Until I had to come up with a story, honorable member, just a small story to help me to be able to deal decisively with these things. And the story was simple, very, very simple. And I would encourage you to make use of that story until you get to a level where you no longer need that story. What is n? N is the house number. That's it. N is the house number. Tn is how many people are living or staying in that house number. Just to keep it simple, honorable member. Just to keep it simple. So that means n is the position number. House number 1, house number 2, house number 10, house number whatever. First term, second term, 10th term, 100th term, millionth term, whatever term, that is the house number. So that means you can't have n, for example, being 2/3. Well, what type of a house number is 2/3? It just has to be house number 2. Nay. The next one is house number 3. And the other one after is house number 4, and so on and so forth and stuff like that. I hope you get my point on that one, honorable member. But in terms of nth term, it's like we are saying in house number 2, there are 3 people, as an example. Then that's when it made sense, whereby when I do a calculation and my final answer ends up being either a decimal, a fraction, or whatever, then I know this one, it refers to how many people, even though it's not practical. Just so that I will know that n will always be, is it a whole number? That number which is just either 2, 3, whatever, it can be 1 over something, can be a decimal. Maybe I'll make sense or some more sense as I continue, but just keep it that way to say, in simple terms, it's like this is a term 1. This is term 1, and in term 1 we have how many people? 2 people. So this is now a first term. And then this is term number 2. How many people? 4 people. This is term number 3. Yes, this is term number 2, second term. Yeah, because we don't have, if this is the first term, this is the second term. Yes, that's what I meant. This is term number 3, third term. So in term number 3, we have 6 people. In term number 4, house number, that we have 8 people. Yes, something of that nature. Okay, then it's fine. We will see how to apply that story where it is applicable. So now what is Tn, being the nth term? So it is just the formula that gives any term. That's it in short. It's like we want to know in term number 3, how many people are there? That's why we will say in term number 3. And then you calculate how many people there are by using this formula, where this will be your first value, and then this will be term number 3, because we want to know how many in number 3, and then here you just substitute to say the common difference was 2. Then you just move all of this on your calculator, and it will tell you how many people are in that term number 3 or term number 4, whatever the case may be. So, okay, I believe that you now fully understand what that formula is all about. So you've got to believe me, honorable member, when I say the questions are not that much complicated. They don't change that much. It's just the same set of questions, but what gets tricky is the pattern itself. But you just follow the same principle, honorable member. So what can we do? Maybe, for example, let's say you are given that 2, 4, and then you have 6, then maybe suddenly you have that and all of that. And then maybe a question would say, find the next two terms. Can you see? If you have to find the next two terms, very much important that before you can attend to the questions, try to establish if this indeed is a number pattern. How do you do that? You firstly try to check if it's a linear pattern. If it's not, then it could be another type. But for today, because we are focusing on this type, then I will show you how you verify if indeed it is. You will always start by finding the difference to say this minus that definitely is 2. That minus that definitely is 2. That minus that definitely is 2. Therefore, it is indeed what is it? A linear, because we have the common difference. Okay, if that is the case, then it means if we want to know what the next term is, we must just make sure that that term, whatever that it is there, it will give us that common difference of 2. Even if we try to find the next, the term after, it should just continue to give us that same common difference. So the only way to do it, the easier way, just say this plus that, and then it will definitely give you what that is, which is 10. So you say 10 plus what you should get as your common difference, it will definitely give you that being 12. Or otherwise, if you want to redo it, you can say it started as 2, they keep on adding 2, and then it gives them 4. And then they keep on adding common difference, it gives them the next 10. Keep on adding common difference, it gives us that. Keep on adding common difference, it gives you that. Keep on adding that, it gives you that. That is how you would therefore work it out. That's if they say find the next two terms, and then you give it as 10 and 12. Yes, that's you answer a question which says find the next two terms. And again, even if they say what is the common difference, you know most. You just do it by just subtracting where you get that. And then the next one, for example, they can still say find the 10th term. So finding the 10th term, you see, they write it this way and say, find the 10th term, or they can do it that way. If not that way, they can do it as 10th term. Yes, can you see? So that means this is where now you will therefore say, use that formula which says Tn is equals to that A that you plus it by N, where you minus 1, you multiply it by D. Already when they say the 10th term, this is the nth term. So when the question says, what is it, 10th term, it means they want to know how many people are in stand number 10. Then a value started as 2, that you plus it with n, 10th term, you minus 1. And then what is your D? There, that D always put inside the brackets. If you don't put inside the brackets, it will give you an error. It's like, if you try to punch, let's say you have 9 inside the brackets and then you just put 2 there, this thing will give you an error until you put this inside the brackets, or in between you say multiply. Okay, so now let's quickly move it on a calculator and say 2, but we plus it with inside there, let's say 10 minus 1, and then in there we multiply it by 2, it gives us 20. So that means it's 20 people which are in the 10th term. So very much important, because this formula helps you. It's like a shortcut. Instead of you adding like this, adding, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, until you get to the 10th term. Instead of you keeping on adding, you just use this formula, and then it will quickly get you to term number 20. Imagine if they say 100th term. You can't keep on adding and adding and adding, and but by the time you get to 100th term, they're going to say it's time up, and that time you only did one question, and then it's a fail. Honorable member, it's a fail, a complete fail. You'll be on the same level as if I asked my grandmother to go to an exam room and just write their name and go home. You will still be in the same level, because that remains as level 1 honorable member. So you don't want a situation where the whole year you go to a school, you study, you cross night and all of that, and then during exam time, I just ask my grandmother to go and write the surname and come back and just chill and cruise nicely. And you stress yourself there, keeping on saying, term number that, term number that, term number that. No, 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 no. Okay, then it's fine. Maybe let's look at some more problems where you may be given different types of patterns, but the method is the so even though the pattern looks different, honorable member, the method, it never changes. Let's maybe refer to this one as a pattern number 2 name, and let's refer to this as pattern number 2. You will definitely realize that this one, it actually involves the fractions. Maybe let's say we have 1/2, and then we have 3/2, and then we have, let's say, 5/2, and then we have, let's say 7/2. Just don't think that 2 is the common difference, because this thing, it is a pattern in a form of a fraction. So you can still be asked this type of questions where they say, for example, what is it? Find the common difference. How do you find the common difference? You will therefore say this minus that. Punch it on a calculator. Be careful to punch it the same way I taught you how to deal with the fractions. Do this divided by name. So that means you will say 1/2, not 1/2. You see now, 3/2, where you wait. What's happening there? Okay, let's cancel that. It looks like this is not what I meant. Please don't call 10,111. So what I meant is you will do the 3/2, then you minus it by 1/2. Yes, this is what I meant. Make sure that your calculator has the fractions. It's able to do this type of fractions. If it doesn't, then you might need to make sure that it's inside the bracket. So, okay, 3/2, where you minus 1/2. What does it? Okay, it gives me 1. Then the next one, 5/2, where you minus 3/2. Oh, yes, it still gives me 1 when I do that. Okay, then it's fine. What about 7/2 minus 5/2? Yes, does give me 1. So can you see, I now have that common difference, honorable member. A very good indication that what I'm dealing with here, it is indeed a linear or an arithmetic numeric pattern. Okay, so that's how you would calculate your common difference. Sometimes they can now say find the next 2 terms. It should be easy because you just need to keep on adding by 1, and then you will get it. And then you add that one again by 1, because you can see that this thing, it continues in that fashion where you just say 7/2, that you add it by 1, so that you get that 9/2. And that 9/2, you continue to add it by 1, it gives you 11/2. Even if you want to know the other one, just keep on adding it by 1, gives you 13 over that, blah, 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 15 over that, 17 over that, 19 over that, But imagine if they want you to give the next million terms. That you can't, well, you can, but it's going to take you maybe 20 years. So we make use of this formula to get to where we want to get to. Sometimes, for example, they would maybe say, determine the general formula of this number pattern, something of that nature, whereby all that they want you to do is like they want you to simplify this, or to find a formula that generally calculates any term. So your formula will have to be in a form of Tn, whereby you will say Tn equals to A. Remember, you start by writing the formula itself. So in other words, they just want you to substitute two things, the A value being 1 over 2, that you plus it with n minus 1. The common difference is 1. They just want you to simplify this, that's all. Where now you will say Tn is equals to 1 over 2, where you say this times that. You see now, mass, that by that by that. And then you end up having, what is it? This will be plus 1n, and then that will be minus 1. So it looks like you will say 1 minus, no, half minus 1. I think that should give you negative 1 over 2 plus n. Yes, because let's see. Half, when you minus it by 1, it gives you negative half. Yes. So as a mathematician, you can just write it nicely to say, me, I'm a serious mathematician. I'll write it as positive n minus 1 over 2. And that is the end of it. So this one is the general formula of this given number pattern, which means if they say calculate term number 1, all that you do is to put 1 where you see n. For example, this question may be saying calculate the nth term. So the nth, not the nth term, but the 11th term. Doesn't matter the 15th term, whatever term, you can still say T11 if it's 11th term, then you will therefore substitute your 11, you minus it by a half. Then let's see. Trust me when I say it'll give you something as something over 2, because I see it just continues by just that and that. Yes, can you see? Gives you 21 over 2. So that means term number 11 or house number 11, it has this many potatoes. Something of that nature, honorable member. Even if you want to test, to check if term number 1, 2, 3, 4, if you want to check indeed term number 4 is 7 over 2, just put 4 there. Just put 4 there, put it on the calculator, and expect to find that. So you can clearly see that indeed the method doesn't change. It's just the number pattern that can be given you in a funny way. Even though it's not funny, but yeah, for some reason it's a funny way. Okay, then it's fine. It's fine. Maybe let's look at this one. Spartan. Pattern number 3, yes. Let's maybe consider this to be pattern number 3. Yes. Okay, then it's fine. Pattern number 3, we can therefore talk about you having maybe, let's say 5, and you have 2, you have negative 1. For some reason, you have negative 4 there, and so forth, and so on, and stuff like that. Okay. Then it's fine. What else can you do here? Same, honorable member, same questions. They can ask you to say, what type of a pattern is this? Then you know very well to say, for you to verify what type of a pattern is this, you must be having a common difference if it is an arithmetic. How are you going to find a common? You see, this minus that. What is 2 minus 5? It gives you negative 3. Can you see? What is negative 1 minus 2? Be very careful when you work it out. In the brackets, a term, if it's negative, you put inside the brackets and say that, and then you minus it by. This one is not negative, no need to that. Definitely, it will give you negative 3 on your calculator. Very, very much important on that one. You will notice when I do this one and say negative 4 minus negative 5. So because 4 is negative, you say negative 4 inside the brackets and you say minus that term is a negative, you put inside the brackets and say that. And you punch it on your calculator, definitely it will give you negative 3. Just punch it on your calculator, will give you negative 3. This is a mistake that you guys make. You just say -4, and then you say -1. Why -1? Because this term is not minus, what is it? It's -1. So the minus, this one is the minus for you to minus the terms, and then this one is the minus being a negative. That's why for me, I use these words nicely. There is something called a negative, and there's something called a minus. Minus is this long one where you minus two terms, or you minus two things. A negative is the one that comes with a term, or the one that comes with whatever that you are minusing with. So just be careful of that part. Punch it on a calculator, it will definitely give you that. So once you get the common difference, trust me, you are done, because all that you need to remember is that we have this formula that says Tn is equals to A that you plus it with, in the brackets you have N, where you -1, and then you've got your D there. Whatever that they want you to calculate, you can easily calculate. I'm now curious to know as to what else they can say calculate. Maybe calculate the next 2 terms or 3 terms. Then you know, all that you have to do, it is to just keep on adding by -3. To get that, you need to add by your common difference to get to that. So that means you will say that -4, you plus it with -3. Very much important, and it gives you -7. That -7, you plus it by -3, and then it gives you -10. So that's how they catch you in exam. Not that this thing is complicated, but they just give you a pattern which is in a form of a negative, knowingly that you're going to make mistakes with the signs. Not that it's complicated, not that it's difficult. So yes, that's how you would work it out. What other question can they ask you, honorable member? Maybe they can say, find the general, what is it? Find the general term of the thing. Yes. Find the general term of this given pattern. So the general formula, it is this one where you say TNC. What is your A? Your A is 5 plus, what is your N? Okay, is the nth term that you're looking for, -1, and then close. What is your D in brackets? Is -3. Very, very much important, that one. So you will therefore say equals 2, and then obviously that by that, it gives you -3n, and that gives you +3. Now you're just dealing with maths modes. Nothing's complicated. What is this plus that? Will it not be 8? It's 8 minus what? -3. So that means this is your general formula there. So even if they say, what is the 11th term of this thing? You know very well that all that you have to do is just say T11 is equals to 8, where you -3 into 11, put it on a calculator, and then it gives you whatever that you get. Let's see, 8 -3 into 11 equals -25. It gives you -2. Remember, it is still correct even if, for example, you find that finally your answer looks like this. You have -3n plus 8. It is still the same, because this part alone, when you compare it with that, it's like you're having 2 minus 4. It is still the same as -4 plus 2, because this 2 has an invisible sign being positive. So you still have your negative there, you still have your 2 there. So don't panic when it comes to that part, honorable member. What else can you do? Somehow they can try to figure out if maybe, let's say, what is it? If maybe, let's say, for example, what is it? Okay, I think I have that question prepared on my notes. Let me quickly check. I think I will get to that one. Yes, I think I'll get to that one. But maybe for now, or in the meantime, let me just introduce you to some more types of patterns that you may be given where they just want to confuse you. Maybe this one would be pattern what? Pattern number 4. So for pattern number, for example, they can say -1, and then next thing you have 0, all of a sudden now you have 1, and the next thing is 2, and then 3, and so forth, and so on, and stuff like that. Trust me when I say key is the difference. If you say 0 minus -1, what do you get? Be careful. 0 minus in the brackets -1. Be very, very careful of that. It will definitely give you 1. Punch it on a calculator, give you 1. And then what is 1 minus 0? It's 1. What is 2 minus that? It's 1. What is that minus is that? So can you see, to get to the next one, you just keep on adding by 1, it'll give you 4. You just keep on adding by 1, it will give you what? It will give you 5. Just keep on adding. That's how you easily work it out, honorable member. Nothing complicated there. Nothing difficult there. For example, they can say, what term number is 30? Before they even ask you this question, you would have gone through that process where you calculate the difference. Okay, the difference is 1, we've just calculated it. And then the nth term, for example, then you will still go on and say, okay, A, that you plus it by n minus 1, close D, and then Tn equals, your A is -1. Very, very much important. Plus n minus 1, your D is 1. Okay, -1, and then plus that by that, you end up having n, and then minus 1 there. This and this will definitely give you -2. So it's like your Tn is the same as, doesn't matter whether you write it as -2 plus n, it is still the same as when writes it as +n minus 2, exactly the same thing. So that one where they say, let's say they say is 30 a number in the sequence, then you can still use this formula to calculate n and verify. Or what term number is 30? It's like they're saying, what is that house number whereby you have 30 people? Something of that nature. Then you will say, okay, where we have 30 people, it is house number, then you solve n. This goes to the other side and then gives you 32. So it's like n is equals to 32. So that means in house number 32, that's where, wait, what am I saying now? What am I saying now? In house number 32, we have 30 people. Yes. Yes, I've said it correctly. So, okay, then it's fine. Maybe let me check on my notes if I've got another type of a pattern that we can go through. Large steps and stuff. Yeah, sometimes they can just, for example, give you the big numbers, because I was just using the small. So they give you that. The thing is, with this topic, honorable member, you just can't go wrong, because it is one of those simple topic where you just need to understand, what am I given? Is this a linear? Okay, if it is a linear, then it's fine. I must find the common difference. After finding the common difference, then okay, so what do you want? What do you now want? The common difference. Okay, the common difference, I will just say this minus that, that minus that, that minus that. Let's see, let's work it out. 12 minus 7, I'm getting 5. Okay, then 17 minus 12, I'm getting 5. Okay, and 22 minus 17, 5. Okay. Okay. Then it means I do have a common difference there. What else you want, examiner? What else? Is 102 a term of the pattern? Is 102 a term of this pattern? So in this case, they therefore want you to calculate n to just verify if indeed 102 is a term of this pattern or not. And then you come back to your formula to say, okay, Tn is equals to, let's say, A, that you plus it with n, where you minus 1, and then you have your D. And then is Tn. Actually, what you are looking for is n. So that means it's like the saying, is there a house where we have 102 people? Then you try to figure it out. And then 8, 7 plus n is what you're looking for, minus 1. What is the difference? The difference is 5. You can easily work it out where you say this to the other side. It minuses then you have 102 minus 7. It gives you 95. Then you have 95, which is equals to that, that, and that. And then here you have that multiplied by. Why do we not divide both sides by 5? Let's divide both sides by 5. Then we divide by 5, just so that we will therefore have, what is it? 19, which is therefore equals to n minus 1. Take this to the other side, and then it becomes 20, which is equals to n. So yes, house number 20, it is the one where we have there's so many people. But most importantly, the answer that you were expecting, it is just, is it a whole number? Yes, you just expect, the moment you get a fraction, then it means that is not part of this pattern, because it just has to be a valid house number, something of that nature, honorable member. Trust me when I say you will see more of this type of questions when we do exam type of questions, because we will definitely get to a stage where now I'm just interpreting an exam question where you need to give it a try, work it out, and see how far you can go and all of that. Because trust me, this type of a pattern, not that much complicated, not that much difficult, and all of that. So yes, that's why just wanted to make sure that in one lesson I cover it, and then we, like, it's a done deal. It's a done deal. It's a done deal whereby once we have dealt with it decisively, the next time we focus on another type of a thing, and then we move it decisively, then we know it's done. And then from there, we focus on another type. And then once that is done, then we know that we jump onto something else. Very, very much important on that one. So just make sure that you watch this over and over and over and over again, and you do as many types of problems as possible so that you get used to how it's being done. I will definitely give you some more problems so that, you will have a lot to do, which forms part of your practice. Okay, and this is now exam style. Where, for example, let's see, is this pattern number 6? Yo, what happened? Where did that go? Trust me, all that I've been writing has disappeared. I don't know why this happens. I don't know. I really don't look at those blank pages. But luckily, because it's on record, doesn't really matter that much. I was just not so sure if this is pattern number 6. I'll just say, I think it's pattern number 6 or pattern type 6, something like that. Because, yeah. Okay, then it's fine. Exam type of questions, they will, for example, give you 2 there. After giving you 2, maybe here they put X. Imagine, put you X and they put 10 there, and then after they put 14 there. What did I say, honorable member? Common difference is the key. So with this type of a question, they will firstly tell you to say, this is a linear equation, or this is an arithmetic, not equation, but arithmetic pattern, a linear number pattern. And they say, find X or solve for X, something of that nature. So for the fact that they said it is a linear number pattern, it means this minus that. What is that? That is X minus 2. So that means X minus 2, it is equal, or it is the same as 10 minus X, because that's what we do for us to get the common difference, isn't it? What we do, honorable member, which means it is still the same as that minus that, which is 14 minus 10. What is that? Is that 4? Yes, it gives us 4. So that means, in other words, this thing is equal to that, and also that is equal to that. So for you to solve for X, it shouldn't be a complicated thing, because you can just see you equate this to this, and then you solve for X. So you can equate this to this, and then you solve for X. It doesn't really matter that much, because what we know is that it has to be the same. So, for example, one can decide to say, I will equate this two. You can say x minus 2 must be equals to 10 minus x. Then you solve for x. You see, now we are back to introductory sessions where now you need to take x to the other side becomes 2x, and then 2 to the other side, it becomes 12. Where now you divide both sides by 2, and then your x is equals to 6. Can you see? Otherwise, if you equate this 2, that means you're having 10 minus x, which you equated to 4. You can take this to the other side, this 2. Then you have 10 minus 4, and then x goes to the other side as well. What is that minus that? That is 6. So can you see? You now back to having your x being equals to. So that means actually the value of that is that. How did they come about this type of a thing? So that's, for example, where they give a number pattern and they said, no, man, this chapter is easy. Let's remove one thing there, and then let's remove it and make it something. For example, now they say, okay, let's even remove this one. You see this 14. Let's remove that 14, and then after removing that 14, let's make it y. It's no longer that, but maybe we put it as y. And then the question will therefore say, solve for x and y. Something of this nature. Then, okay, let's see now how you would have to go about it if it is given to you like that. Okay. If it is something which is given to you like that, you will still have to say x minus 2. It must be the same as 10 minus x. And also, it must be the same as y minus 10. Yes. Here, I'm just giving you an example, honorable member, as to what you might need to. So that means what you know is that this thing is equal to that. Also, this is equal to that. So why not solve it simultaneously and say this and that I will equate and find the x value. So that means you'll say x minus 2. You know it's supposed to be equals to 10 minus that because it's the common difference. So I think we've already solved it where you take that to the other side, becomes to that, and then this one becomes 12, and then your x ends up being 6. I'm sure you know how it ends up being 6. Now you are done with the x value. Then you come back to this one to say, again, this 10 minus x, it must be equal to that y minus 10. Yes, something of this nature. Already you have calculated your x value. So you'll take that x value and put it there. So that means you have 10 minus 6, which is equals to y minus 10. Yes, something of this nature. And then what is this minus that? Is it not 4? That is 4 most. Yes, that is 4. And you have that, and then minus that. So what else are you having? If you take this to the other side, it becomes what? 10 plus 4, which is 14. So that means your y is equals to 14. So let's see, y is equals to 14. Oh, yes, indeed, we expected a 14, honorable member, because remember, originally you had this thing here as 14. Then I just removed it and I placed y there. So that's what I mean when I say they just replace what you already know. For example, that 2 there, they will just replace it there and put p there. They put p there, and then what else? So now you have that p there, and then here, there where it's x, it can't be too many letters in most cases. They just give you 2 different letters, and then you just have your 6 there, and then there you having your y, doesn't matter. And then they say find p and y. Easy. This minus that. Manje. I'm telling you, manje. What's next is for you to try and do some more that I will give, and then you submit, then I see where you struggle and all of that. Okay, then it's fine. Let's look at some types of questions that you must cover, which is actually the exam language that you might need to expect, where they would say, for example, find the next two terms, find the common difference, write down the formula for Tn, or find the nth term, or maybe find the value of a specific term, e.g. maybe they say T12, something of that nature. Maybe they say determine which term determine which term a given number is. Yeah, something of that nature. Determine whether a number belongs to the pattern. Yes, where you find n indirectly, then find for x in a linear pattern where you just do what I've done. Yeah, something of that nature, honorable member. I think I'll be fair and give you or test you on things that I've already done so that you gain that confidence before I give you an exam type of a question. Yes, I think it will be that way, honorable member, way. Yeah, something of that nature. If you ask me, okay, then it's fine, it's fine, it's fine, it's fine. What else? Once you know or understand about the A, the D, and the nth term and n, I'm telling you, linear pattern becomes very, very much easy, no matter how scary it looks, honorable member. And then, yeah, then you should be done. I think I'll just leave it here and say, until we meet again. Hope you did learn a thing or two there. I definitely hope that. Why is it like now?